So here we are back again, another AP question to do. This time we've got the 2009 exam, Form A, the second question on the exam. So the situation we have here is a tire manufacturer has got these new tread patterns, this new tread pattern for their tires, and we're going to test the stopping distance when the cars are traveling at 60 miles an hour. The test showed that the cars stopped on average for 125 feet with a standard deviation of 6.5 feet, and that the stopping distances are approximately normal. So I guess in this problem, we're assuming that if our random variable is x, and x is the stopping distance for a car with this new tread tire traveling 60 miles an hour in feet, that the x is normally distributed with a mean of 125, standard deviation of 6.5. So A looks like it's just going to be a question using the normal distribution, finding a z-score and whatnot. Part B, though, looks like we're going to randomly select 5 cars, and then we're looking for the probability that at least 2 out of them stop at a greater distance than that 70th percentile. That situation looks like it's binomial because there's 2 choices. The car either stops farther than that distance or it does not. We're selecting a fixed number of cars. We're assuming that each car is independent of every other car, and that the probability of stopping further than that 70th percentile, well, that would be 30%. So that's going to be a problem using a binomial distribution. And then C asks us for what the probability is that a randomly selected sample of 5 cars will have a mean stopping distance of at least 130. So that's going to be using the sampling distribution. So what do we got for the intent of this question? So the primary intent were to assess the student's ability to calculate a percentile from a normal probability distribution. Yep, that's what I was thinking. Recognize a binomial scenario and calculate an appropriate probability. Great, no surprise there. And then use the sampling distribution of the sample mean to find a probability. So no surprises in the intent. So let's check out what the College Board did for Part A. So they defined their variable. They said let x denote the stopping distance with the car wearing the new tread tires. Let's see if I can actually, can I highlight that? That doesn't seem to be working. Hold on. Sorry, just some technical difficulty there. Okay, so they're defining, the person that wrote the solution is defining the random variable x. That sounds great. They're saying x is normally distributed and giving the mean and the standard deviation. And then they do all this work. So I would have liked to see in this, nowhere here do they, I would have done a little sketch where we're saying that the mean stopping distance is 125 feet, and we're looking for the 70th percentile, so we're looking for this x value such that the area to the left of that x value is 0.7 and the area to the right is 0.3. So on our calculator, we could have done inverse norm of 0.7 to get the z-score of 0.52. Remember, you do not need to write the calculator notation on the exam. It doesn't count for you in any way. And then I would have written the formula for the z-score, x minus mu over the standard deviation, and then sort of plugged in values, x minus 125 over the standard deviation, which is 6.5 feet, and then solve that for x, and they get that x is about 128.4 feet. So notice there's nothing really wrong with their answer per se. It's just that I would have liked to see the picture there and the formula for the z-score written out and then substitute in the values. So just some details there that I would have liked to see. But there's Part A, so just a little bit of work there using some of the properties of the normal distribution, and then that's that. So now for Part B, we have to recognize that the situation is binomial, so I like how they defined a new random variable y, the number of cars with the new tread that stop greater than 128.4 feet. They say y is binomial. Notice how they're saying what n and p are. So they're giving sort of a great description of the binomial distribution. And then they're solving that probability. So they're saying this is the probability that two or more of the cars have a stopping distance greater than 128.4 feet, which is the complement of the probability that one or less cars have a stopping distance greater than 128.4 feet. So this probability that y is greater than or equal to 2 is the same thing as 1 minus the probability that y is less than or equal to 1. And then they're working out sort of that probability. If you did not want to do it that way, if you just wanted to write out sort of the probability on the probability that y is greater than or equal to 2, so that would be you're choosing out of 5 cars, 2 are stopping at a distance greater than 128.4 feet. So that's 0.3 to the second power. Since there's a 30% chance that a car stops, that the stopping distance for a car is greater than 128.4 feet, and 0.7, that means 3 of the cars will stop in less. Again, I'm sorry, I'm still getting used to the tablet here. So then we have to take into consideration the scenario that we've got 5 cars and 3 of them stop past that distance. So that'd be 0.3 cubed and then 0.7 squared. That means 2 of them won't. And then add that to 5 and 5 choose 4, 0.3 to the fourth, 0.7 to the first, plus down here 5 choose 5. So that's all of the cars stopping past that distance, and none of them stopping short. So you could have done it that way. So I see why did the College Board do it that way. It was a little bit less to write, so they were using that complement probability. So remember, the key idea here is that the stopping distance of 128.4, that stopping distance is the 70th percentile. So that means there's a 70% chance that you stop shorter than that. The car stops in a distance shorter than that, and 30% that the car stops at a distance greater than that. So there's only those 2 outcomes. And then we're assuming each car is independent of every other car in terms of stopping distance, and that the probabilities are fixed. It's 70% and 30% each time. And that we're just taking 5 cars, so there's sort of a fixed number of trials. So it was a great review of how the binomial distribution works, working that into the question. So remember, you could have used your binomial CDF function on the calculator. Some of us have programs written and things of that nature. So a bunch of different ways to do that easily. I mean, you could have just cranked the probabilities out on the calculator as well. And now for the last part C here. Now we're randomly selecting 5 cars. So what that means is that the mean of the sampling distribution, the mean is still going to be 125 feet, but the standard deviation of the sampling distribution is now going to be, 6.5 feet divided by square root of 5, 6.5 being the standard deviation of the original distribution of the stopping distances of just single cars. So I like how whoever made this answer, they're defining what X bar is, the mean stopping distance of 5 randomly selected cars, and then they're saying that they're describing the distribution of X bar. They're saying it's normal, they're giving the mean and the standard deviation. Notice they're including the units, like the mean's 125 feet, the standard deviation is 2.91 feet. And then, like, thinking in terms of the central limit theorem here, we were assuming that the distribution of individual stopping distances, that was normal. So the distribution for all possible randomly selected groups of 5 cars, of all those possible X bars, then that's going to be normal as well. That's what the central limit theorem sort of is telling us in this case. So they're doing a good job of describing the distribution. And then what I don't like is that they're sort of shortchanging some of the work here. Like I would have loved to see, oh, see, that's not good. I would have loved to see a picture here. So I'd love to see like a little sketch of the normal distribution, the sampling distribution in this case, with 125 in the middle, and 130 is going to be all the way out here. And then I would have liked to see, well, actually, no, they got the probability statement right here. The X bar is greater than or equal to 130. Then they're actually solving for the z-score and putting that right in the probability statement. That's absolutely great. I mean, normally I encourage you guys to write down the formula for the z-score. So you could say x bar minus mu of x bar over sigma of x over root n, or instead of sigma of x over root n, I could have written sigma of x bar, either way. So I kind of like how they did that there. And then they've got the answer, and then they even wrote, they sort of summed it all up, you know, with this writing here, but I always like to see a picture here. So just a couple of minor details that I wasn't crazy about their solution, mainly just not including sort of graphical representations. But other than that, pretty straightforward, not that hard. Hope this helped a little bit. I'm sorry the videos are all over the place, still getting used to the software. Hopefully looking to iron out all these kinks, and I'll be back with a video in the future. Good luck on the midterm.